Hi, my name is Ethan. I'm in the Mechatronics program. This is our metal plastic sorter. I did the electrical and the PLC programming.
My name is Liam Shang, and I was a part of the CAD design for the project.
My name is Fred, and I did the pneumatics for the metal and plastic sorter.
The importance of this project is to show that we can properly demonstrate how to use automation in a correct way where it is useful out in the workforce.
The reason why we decided to build our project is because we want to keep it simple while also keeping our build and design time in mind so that we can complete it in a timely fashion.
So here's our metal plastic sorter. I'm going to start off by giving you a timeline of what we did. For the first 8 weeks, we had about 14 class times to work through this and design it. Look up specifications, make sure everything worked and fitted together. And then for the next 8 weeks, it was the building it, machining it, making sure all the parts fit together, and then testing it. So this is the electrical and the PLC programming part of it. On here is the PLC and all of the inputs and the outputs leading in and out of it. Starting with the inputs, there's the capacitive and the inductive proximity sensors. The capacitive will sense just about any object, including plastic. The inductive will only sense metal objects. You have your cylinder switches, which is P1 and P2 here, which using a magnet inside of the cylinder, once that passes by, it closes two contacts and allows continuity through them. We have a selector switch, a couple photo eyes, and some push buttons. Leading out of it, we have a yellow light, an EMR with some contacts down here, a couple solenoids for the DCVs, and a conveyor motor, and fuses leading to all of them for safety. Here's the PLC program. There's 26 lines of it, with all the inputs being on the left side and all the outputs being on the right side of it. And then going into my folder, these are all the PDFs for the electrical objects.
So this is a pneumatic schematic, and I got air coming in from the test lab, and we have a filter with a pressure regulator from McMaster-Carr to a gauge, and this feeds two SMC valves. And a valve on the left here goes into two flow controls, so you can adjust the flow into the top cylinder, and at rest it is fully retracted. And on the right comes out a valve into two more flow controls into a fully extended cylinder. And the reason why one is retracted and one is extended at rest is so they can hold the pucks in the escapement. So at rest, the pucks will be sitting on the top of the cylinder, and when we run the program, the top one will extend while the bottom one retracts, dropping the puck on the conveyor. It's pretty simple, but basically I got two valves, 4 flow controls, and 2 cylinders.
Here we can take a look at the SolidWorks design. As you can see, this is the front view of our project. On the back is where a panel where all our pneumatics and electrical is laid out onto. The PLC is located right here, and the buttons to operate are right here. Originally, this project was seen as a vertical layout, but unfortunately when we figured out how long the minimum length of the conveyor was, then we had to switch to be horizontal. But other than that, and a few other hiccups, like the bin where the pucks drop onto, where that needed a redesign. Design came out perfectly.
Okay, so this is the back side of the metal plastic sorter. This is all the things that we designed. We made brackets for it to fit everything to this 80-20. But we can start out, we have our power supply, our EMR with different contacts in there, our E-stop, our PLC, all of our conduit, our push buttons, our light, our selector switch, some fuses for safety. Here's where we terminated all the wires. We have our DCVs, our flow controls, and our pressure regulator. Alright, so here's a simple operation of the machine. There goes the plastic puck. And the metal puck. Alright, thanks for watching.